In this tutorial, we'll see how to build XBAR and R charts for statistically controlling a process. XBAR and R charts are control charts for continuous variables measured from a production process. They allow us for detecting deviations from the expected behavior of our production. We'll start from an example Excel file called xbar and rcharts.xlsx. This file comprises three worksheets. The first one, called data, contains the data on the process we are trying to control. The first column, the item column, serves as an identifier, and the observed value column represents the weight, length, or any other continuous control variable for each product. We have collected measures for 100 products. The second worksheet contains a set of values for the 3 sigma table for samples comprised of between 2 and 15 items. D3 and D4 columns are used to estimate the control limits in the R chart. More complete tables can be found in reference book text and on the internet. The third worksheet is prepared to show the XBAR and R charts, and it's where we'll work. It contains a description of how we are going to group our measures, a set of parameters required to build the charts, a section where we will prepare the data to be represented graphically, and of course the two charts that we are trying to build, the XBAR chart and the R chart. So let's start. We are going to take 20 samples of 5 items each one. These are typical numbers when these kind of techniques are used. Now we'll work with the data to prepare the charts. We need to calculate both the average and range for each one of the samples. To calculate the average, we only need to use the Excel function average. Just click on the corresponding cell for sample 1 and write equal average open parentheses. And now go to the data worksheet and select the first 5 observed values. Close the parentheses and press the Enter key. To calculate the range, we need the maximum and minimum values for each sample. Thus, we will use the max and min functions. We have to select the same range for both functions, so we'll copy the one used in the average function used previously. Just write max, open parentheses, write the range, and min, the range again, and that's all. We could repeat this step for every sample. Instead, we'll use a very useful Excel function, which is called offset. Offset returns a reference to a range of cells, and we can use it to automatize these calculations. We'll see how to configure its parameters in our example. Anyway, let's help the offset function a bit. We'll just add a series of numbers starting by 0 to the left of the sample name, that is the column A. We need to rewrite the average and range functions, so just go to the cell that contains your average function and substitute the range, explicitly defined, by the offset function. In the offset function, the first thing we have to define is the reference, and our reference in this case is the first cell where the data is, that is the data C3 cell. That's all. We'll switch it to an absolute reference by pressing F4, and now we have to define the rows parameter. In this case, the rows parameter is the product of the tricky value we added and the sample size. Again, we'll press the F4 key to make it an absolute reference. We'll write a 0 in the calls parameter since we are not moving from the reference column. And now we have to add an optional parameter to tell the function to create a range of 5 cells. Again, this parameter is the sample size. And again, we'll do it an absolute reference. The range for the max and min functions is exactly the same. We copy it from the average function and paste it where appropriate. Copy, and now substitute the ranges in the max and min function by the new range built with the offset function. Finally, we only need to apply our functions to the rest of samples. So we select both functions and drag them to row 44. Just be sure that you only drag the functions and not the format, just not to spoil the final appearance. And now we can see the average and range for each sample in the corresponding charts, but we haven't defined the control limits yet. The functions to define the control limits in an X bar chart are very easy to use, and they only depend on the average of the averages, the sample size, and standard deviation of the process. The R chart depends on the average of the ranges and some parameters extracted from the 3 sigma table. So let's fill the average of the averages. Here you have. And now we have to fill in the average of the ranges. So we select all the ranges for each sample, and here you have. The standard deviation of the production should come from a previous study or long observational data. In this case, we'll use 0.08. The set value is usually set to 2 or 3. Let's try with 2, just to be a bit more exigent with our production. The next parameter is the standard deviation with respect to our samples, that is, the standard deviation of the production divided by the square root of the sample size. The more items we collect for each sample, the lower this value is. So the square root and the sample size, that is. As you saw in the previous slides, the functions for the upper and lower control limits are very simple, and we just need to use the values previously computed. So we can write the upper control limit, the center line which is the average of the averages, and the lower control limit. That's it. Perfect. In the case of the R chart, we need to use the 3 sigma table. The upper control limit depends on the value that we can find in the D4 column corresponding to our sample size, that is 2.114. The lower control limit depends on the D3 column, and in this case is 0. In order to make our worksheet more useful for future projects, we'll make use of the Excel lookup function, more specifically the vertical lookup function. This function looks for a value in the leftmost column of a table and returns a value in the same row from a column you specify. So let's fill in the function, so equal VLOOKUP, and we have to fill in 3 parameters. The first one is the value we're looking for, that is our sample size. Okay, the second one is the range where we want to look for this value, that is the table 3 sigma range, which was already defined. Here you have. And the column where we expect to find the corresponding value, that is the 4th column. Here you have. For the lower control limit, we have to do the same. So let's write the function VLOOKUP. Again, the value we're looking for, the range where we want to look for this value, and finally the 3rd column. This time, here you have. And the center line is simply the average of the ranges. As you can see, the charts now show how well is your production process behaving in terms of both central tendency and dispersion. From these charts, your conclusions should be that no apparent problems of the dispersion are present. So here almost all the values are well balanced around the center line. However, samples 11th, that is 13th, and the 20th had some degree of deviation from the expected average. Consequently, further research should be performed on these samples in order to identify potential sources of problems for our production. And that's all. Now you can build your own XBAR and R charts.